Okay, I'm going to do a couple of Hess's law problems for people who missed out on things. What is Hess's law? Hess's law is a theoretical way of determining the heat of a reaction. So an actual way of determining the heat of the reaction is to set up a calorimeter. A theoretical way is to go into a book and look up values. So if we have a reaction that's too dangerous to do in the lab, we can go, or if we don't have the equipment to do this reaction, we can go and look up known values. If these add up to this reaction here, we can find the heat of the reaction. So the whole trick here is to ignore the elements. So what I'm going to do is I'm going to look for the molecules in the reaction. C2H4 is a molecule. Here it is down here in the first reaction of the three that we're trying to add together. Note that it's on the reactant side, just like this C2H4, and we have the proper amount, so we're good. Now we look for H2. Wait a minute, H2 is an element. This is the simplest form of hydrogen. Certain elements are diatomic: hydrogen, nitrogen, oxygen, fluorine, chlorine, sometimes bromine and iodine. So we're going to ignore that. Now we look for our next molecule, C2H6. Here it is right here. It's in the wrong spot. It's supposed to be on the product side. So we're going to flip this reaction. So I put little symbols down when I do things, and that way I leave all my numbers till the end. So that's just how I do it. There's more than one way to do this. So I'm going to write this reaction out again. Once I write a reaction out, I cross it out so that I don't confuse it. Now, if you ever have a molecule down here that's not up here, it means you're going to be using that molecule to get rid of things, and we'll show you what we mean by that. Now what I have to do is I have to add everything up. How do we do that? First of all, we get rid of things that we can. So we're going to get rid of that 2CO2 because there's 2 on the product side, 2 on the reactant side. Now, you might have noticed that I don't write my states in gas, liquid, solids, but one thing I want to say right here, if this was 2CO2 gas and this was 2CO2 solid, you can't cross those out. So they have to be the same state to be able to cross things out or add things up. What do we want to take a look at next? Let's take a look at our H2Os. I've got 2 H2Os on the product side, plus I've got one more down here. That's 3 H2Os. This H2O plus these 2 H2Os are going to be used to cross out these 3 H2Os. Let me tell you a little secret. If you find all the molecules in the beginning and get them in the right positions with the right amounts, everything will cross out or add up. I have 7.5 O2s here, 7.5 O2s here, and 3.5 O2s. Guess what? Those will cross out. 3 is the same as 6 over 2. 6 over 2 plus 1 over 2 is 7 over 2, and that'll cross this 7.5 O2s out. If you really get lost on a test, I shouldn't be saying this, but you can always fake your way through it, because if there's no O2s up here, they will cross out. They will. There's an H2 here, an H2 here. I leave my elements to the end. If I take care of my molecules, the elements take care of themselves. What do I have in this right here? I've got C2H4, plus I have H2, and I have C2H6. If you've done this right, this bottom line down here will look exactly the same as your target. That's your proof that you did it right. Now what we do is we add up our numbers. But because we flipped this reaction, we have to flip the sign here. So this becomes a positive. Once again, that was negative 1560. When we reverse a reaction, we reverse the heat of the reaction. Don't lose sight of what we're trying to do here. We're trying to find the heat of this reaction. So right now, I'm just punching numbers into my calculator. and I have negative 136.8. And what that tells us is that this reaction gives off heat. The units are kilojoules per mole. Instead of writing down delta H equals and the number and the units every time, I just write the numbers in. I find it gets too messy if I try to write all of the gases, solids, liquids in, and if I try and write everything in as I go. So I try and neaten it up. This means if we burn 1 mole or react 1 mole of C2H4 with hydrogen, we are going to have an exothermic reaction with that much energy. Let's try one more. My first step is to find all of my molecules, get the right amounts in the right places. So I have 4 ammonia right here. Here I don't have 4 ammonia and I've got them in the wrong spot. So what I want to do is reverse this and multiply by 2. I always put little symbols when I do things, and that's going to help me with the math in the end. So I go 4NH3 because I'm multiplying it by 2 as I flip it, 2N2 plus 6H2. The most common error in these problems is sloppy errors. Be careful as you go. O2 is an element. I don't even look at it. If you take care of the molecules, the elements will take care of themselves. So I've got to multiply this line by 2. If I'm really careful, I don't write it out again. This one, I can get away with not writing it out again. But you've got to be careful when you go back, because you ask yourself, is that a 2 or a 4 there? So there is a risk involved in not writing it out again. So I have my 4 NOs taken care of. Now I'm going to take care of my 6H2O. I see that I have 2H2O. I'm going to have to multiply by 3. Once again, be very careful not writing things out again. Everything should cross out now. So there's no N2s in the target, so my N2 should cross out. There are 5 O2s. I've got 2 and 3 there is 5. There are no H2s in my target, so I should be able to cross out my H2s. I'm going to put a double line there so I know that I'm working down here. So I got rid of my H2s. So what do I have left? I have 4NH3 right there. I've got 5 O2s. I've got 4 NOs. And I've got 6 H2Os. Now all I have to do is add everything up. I'm not going to add everything up, but I'm going to tell you what you have to do to get your final answer. You have to multiply that by 2, so you would get negative 361. You've got to reverse the sign here because we flipped this. So this would now become positive and multiply that by 2. And you would multiply this by 3 and you would add the numbers up, and that gives you the final answer. I just wanted to go through show you the process of how I think my way through Hess's law problems. I feel like if you get caught up on looking at all the little elements as you go through, you're going to get lost. That's why I get all the molecules in the right spot with the right amounts, and then all the elements will do what they are supposed to do.